Hello, we are going to use the trig hexagon to know the integral of trig formulae. Please do not memorize the formulae, but get to know the integral of trig formulae. Subscribe to Sinapelos, my YouTube channel. In this presentation, we are going to use the trig hexagon to know the integral of trig formulae. The purpose of this presentation is to make it easy for maths and science students to know the integral of trig formulae without memorizing them. What's trig hexagon? It's hexagon with 6 trig function names on each vertex that help us to remember so many formulae and identity. How? Let's start by drawing the hexagon, then join all the opposite vertices to get 3 diagonal lines and introduce one at the middle of the diagonal line. Thus, one hexagon will help us to derive so many formulae. Of trig are sine, cosine, tangent, cotangent, secant, cosecant. We begin on this vertex, moving in clockwise to end here. All you need is to remember this trig function, that is, tan is sine out of cos. So we start on the vertex and then write tan, sine, cos in clockwise direction. What about the rest other function? Don't worry. That the opposite of cotangent is tangent. Therefore, cot is the opposite of tan. All you need is to remember is that tan is sine out of cos. Using tan on the first vertex, sine on the second vertex, cos on the third vertex, cot on the next vertex in clockwise direction. Remember, all functions starting with c on the right side, then cosec before sec. Now that we know how to draw the trig hexagon, we are going to use the trig hexagon to know the integration of trig function formulae. We know the integration is the reverse of differentiation. We will use the trig hexagon to know the derivative of trig once again, and then reverse it to get the integration of trig function formulae. Let's draw the trig hexagon. Please take note of this. If we differentiate all trig functions begin with c, that is cos, cot, cosec, their results are negative of a trig function. 2. If we differentiate tan and cot, always their results are square of a trig function. 3. If we differentiate sec or cosec, always their results are the same sec or cosec multiplying a trig function. We will use 3 sides of the trig hexagon to know the derivative and the integral. Observe the movement of the arrows. Let's begin. Derivative of sin s is cos s. The reverse is integral of cos s is sin s plus c. Derivative of cos s is negative sin s. In note 1, if we differentiate all trig functions begin with c, that is cos, cot, cosec, their results are negative of a trig function. The reverse is sin s is negative cos s plus c. Derivative of tan s is sec square s. In note 2, if we differentiate tan or cot, always their result is a square of a trig function. The reverse is integral of sec square s is tan s plus c. Derivative of sec s is sec s tan s. Note 3 says if we differentiate sec or cosec, always their result is the same sec or cosec multiplying a trig function. The reverse is integral of sec s tan s is sec s plus c. Derivative of cot s is negative cosec square s. Here is the combination of note 1 and note 2. Its reverse is cosec square s is Then derivative of cosec s is negative cosec s cos s. Note 1 is here, there's a combination of note 1 and note 2. The reverse is integral of sec s cos s is negative sec s plus c. In our last presentation, it's difficult to take the integral of this trig function, that is tan, cot, sec, cosec. The integral of this function gives us a natural log. Observe the movement of the arrows. Note, always there's a negative attached to all functions begin with c. Let's begin. Integral of tan s is ln of sec s plus c, or negative ln of cos s plus c. Integral of sec s is ln of sec s plus tan s plus c. Here, there's addition. If you differentiate sec s, you will get sec s tan s, but here there's addition. Integral of cot s is negative ln of cosec s plus c, or ln of sin s plus c. Integral of cosec s is ln of cosec s minus cot s plus c. The next presentation will be using the trig hexagon to know the integration of hyperbolic function formulae. All you have to do is to subscribe Senior Pelus on my YouTube channel for more videos. Thank you.